was, we've already talked about these, we're just clarifying it more. So when we have a numerical base, so E is a number, right? Just like pi is a number. Non-repeating, non-terminating decimal. E and pi are numbers. So when we have a numerical base to a variable exponent, we will always rewrite it, ln the base, derivative of the exponent. So if I have a numerical base to a variable exponent, like I said, we will rewrite it. So this is rewrite. Numerical base to variable exponent. We're going to rewrite it. Do you agree? Yes. Then we ln the base. What's the base of this one? Ln E. Ln the base. Okay, guys, stop. And then we follow behind with the derivative of the exponent. If the exponent is sine x, what's the derivative of that? Cos x. Now, E is a special one because the ln doesn't exist in the next step. Why? Because ln of E is 1, because ln E is log base E of E, right? So we've talked about this before. Ln of E is the same as log base E of E. We were taught in grade 12 that you can actually divide those and put a log down here. Well, what is log E divided by log E? 1. So that's why ln of E is 1 every single time. Okay? So in this case, this one goes away. If our base, though, if our numerical base is not E, the ln will stay. So if our numerical base is a 4, we're going to have a ln 4 in it as one of the chains. All right? So the answer to this one is just going to be cos x E sine x. Or you could write them the other direction. It doesn't matter because it's multiple choice. I mean, it's multiplication. Now, because it was cos x, I stopped there. If it was cos 2x, I would put cos 2x, and then I would put another chain of 2, right? You have to do the derivative of every single thing. So let's look at this one. It's e to the secant x. So g prime of x, it's a numerical base. 2 is a numerical base, and there's a variable in my exponent. Whenever that happens, I will rewrite it as my first step. Ln the base, so ln e, which becomes a 1. And then the derivative of the exponent, what's the derivative of secant? Secant x tan x, okay? The x happens to be a 3, though, 3x, right? So we have to write it out that way. So we get a chain behind it of secant x, which is secant 3x, tan 3x. And then am I done? Remember that you can say you're done when you've done the derivative of every single thing. What's the thing we have not done the derivative of? 3x. The 3x. So what do I have to multiply behind with? 3. No. No. It's secant 3x, tan 3x, but the actual original had 1 3x. You're not going to do 2 3's. So you will still only do 1 3 because you're doing the derivative of the original, which had 1 3x in it. That one only has 2 because you took the derivative of secant, which is secant tan. And then it often gets rewritten with the 3 in front. So they'll go 3 e secant 3x times secant 3x tan 3x. Box here. So is h different?
Yeah.
It's only different that the numerical base is a 5 instead of an e, but is it still a numerical base to a variable exponent?
No.
Yes. So we have a numerical base to a variable exponent. Our derivative says to rewrite it. Ln the base, so ln of 5. Does that go away this time? No, ln of 5 is a decimal. We don't want the decimal. We just write ln 5. And then we follow behind with the derivative of the exponent. What's the derivative of 3x squared minus 2x? And then we could take that 2 out, right? So if we take the 6x minus 2, we bring it to the front, I can take a 2 out, and then I'm left with, no, I can take a 2 out of the 6x minus 2, so I'm going to be left with 2. Take a 2 out, I'm left with 3x minus 1. So that's just this rewritten at the front with the 2 taken out. You see what I'm saying? Okay. Then I rewrite the rest. 5, 3x squared minus 2x. Ln of 5. You try it out. So we are going to, it's a numerical base to a variable exponent. So we are going to take the derivative of it. We do f prime of t. There should be a t. I don't know why I have an x there. Fix that. Or put this as f of x if you so choose. I don't really care. So we rewrite it. 8 root t. Ln the base. So ln of 8. Oh, I don't know what I'm writing. Ln of 8. Now, that's t to the half, technically, correct? So I have to follow behind with the derivative of the exponent. What's the derivative of t to the half? 1/2 t to the negative 1/2. Now, the other ones we did was a product rule or a quotient rule, and then I would have to take the half out of the two terms. Do you agree? Is this a product rule or a quotient rule? No, it's just chain. This is all one term. Do you see how it's all one term? Life is easier when it's all one term. The 2 just drops to the bottom, and t to the half just drops to the bottom. There's no GCFs to take out because there's only one term. You can't take a GCF. There would be no point. So when it's chain rule, it's actually easier. The 8 root t stays on the top. Ln of 8 stays on the top. 2 can drop to the bottom, and then square root of t because it's positive 1/2. So it's easier. When you have to take out GCFs and quotient rule, it's harder. Sorry, if you take GCFs out, it's because of product and quotient. Product and quotient gets you more than one term. The plain old chain rule doesn't. So if you're not using product or quotient, you don't have to do GCFs. It's all one term. Okay, this one we've already talked about, so I want you to try it out. What's the first thing we're going to have to rewrite this as? How do I rewrite this? Tan 3x squared minus 2x, what? All cubed. Right? Try it out. Our first step, f prime of x, is to take that 3, drop it in front, and rewrite it. Tan 3x squared minus 2x to the 2. Which, guys, we're going to have to remember to bring back into here at the end, right? You have to remember to bring that 2 back in between. You're not going to leave it out in the brackets. That's where people just often forget. Now we do the inside brackets. What's the derivative of tan? Secant squared x. So my x happens to be 3x squared minus 2x. Am I done? What do I need to do next? 6x minus 2. So the 6x minus 2 will often come to the front because the 6x minus 2 actually breaks down into 2. 3x minus 1, right? So the 2 and the 3 will join and make 6. This 2 and this 3 join to make 6. Then I'm left with 3x minus 1. Then I need to remember to take this 2 and drop it back in here. So then I'm going to get tan squared, because the only time it's not dropped in there is if it's a 1. And then I have secant squared 3x squared minus 2x.
come it's secant squared and not secant cubed?
Because the derivative of tan is secant squared. Where were you getting the cube from, actually? This 3 comes out, and then we drop it in front, rewrite the middle, and then it says squared. So now the secant squared is just the derivative of tan.
Oh, so we're going off that one then?
Yes. Does that make more sense? Okay, I want you guys to try K and K. Why do I have 2 Ks? What's better than 1 K? 2. All right. So here we have sine, cos, tan x. We have sine, cos, tan x. How many x's do we have? We have 1x. We agree? So can we do product rule with it? We have sine, cos, tan. Can we do product rule when there's 1x? No, you'll do product rule when there's 2 x's. So we have to chain. We do the derivative of sine, rewrite the inside. Derivative of cos, rewrite the inside. Derivative of tan. So you're chaining out. So derivative of sine, rewrite it. Cos, rewrite it. Tan. Okay? This one, what's the catch on this one? It's x cos 2x. So to do the derivative of the exponent, you actually have to do product rule. The derivative of the exponent is actually product rule. So do this one, do the derivative of sine, rewrite, cos, rewrite, tan. And then this one you do rewrite, ln the base, and the derivative of the exponent is a product rule. So try it out.
Now you do the derivative. And then once you do the derivative, then you do the derivative.
I just asked Crawford what the link is to the basketball game tonight. All he wrote back is, you have to pay. And I wrote back, yeah, I know. Can you give me the link to the game? All provincial games are paid. Which is kind of crazy because I think it's per game, whereas provincial basketball would have like a walk of games. Provincial football is 1 game.
Yeah.
But I think you can buy it per month, or you can buy it per game. Which football makes sense to buy it per game because it's provincial finance. I don't pay anything. I paid for your ticket. I paid to watch the football game. It was also the So coast and then you try to
Yeah, so coast and then coast 10.
yeah.
And then
You chain out the coast one now.
So here's going to be you're taking this close right here. Oh, then you need
It's called go to any type of freaking Thanksgiving. I'm like, if the little child behind me picks up the finger and the drunk person behind me picks up the beer on me, I'm gonna
I went to one game and they had like the sticks.
Oh, yeah, those are great.
It's like in the head. People were like screaming and it was like beer towers.
Oh, yeah.
And then they fall. And like you have to get at your face. They're like kissing. It's like you're hitting people down the stairs. And those
Absolute worst one that was for me was little kid behind me. He was just like pedaling right beside his dad. I'm like, why do you waste money for like not like if my kid lived there with death, I'm like, down. You would pay time. So finally, I couldn't go anymore. And I looked at his dad and I said, I see you stop. And then I looked at his dad and I was like, that was great. There's a dad for him. And then no joke. Dad gets off and I looked up and I was like, stop. Like, I was like, I tried to see. Yeah. Like, he's like, you're fucking gay. Like, I was like, 3, 2, 1. Like, what the heck? Like, I was trying to get about it, but I was like, the difference is that we never, like, I wasn't one of those people without children who was like, oh my gosh, no, I would have like freaking feet down. And they're like, but their feet, I'm like, down. Like, don't. Next time they're like, no one wants to, but if they're going in front of you. Brackets, good. Better than one bracket. 17.
I know. I don't know if I did that part right, but
That's okay. There's lots of chain roll is just full of brackets.
yeah. I don't know.
Me too. It's like it gives me like little joy. Like sequential order of just doing it. It's like mathematics. You just like kind of brainless. It's like you know what the trick is. Right? It's not like it's like strings. Like those are all just. So you're going to do F times G prime, right? Oh, so your G prime is going to be
K or K? Evidence.
Right here. So we're going to go through the K and the K, which I don't know why I have 2 Ks. Oh, I know why. I had to put the K, and then when I put here L, it autocorrects you to whatever the last one was. And I'm like, you're not helpful, autocorrect. It's painful. Yeah. I was like, oh, it drives me nuts. It's like, oh, it must be K, because there's a J here. I'm like, no, put a K there, but you didn't recognize it. Stop autocorrecting. Quit it. You're not helpful. I yell at my screen a lot. That's why I would actually K. Okay. Shh. So, forgot to press that and I ran to vote. Forgot to press record. Oops. Okay, so we work from outside in. The derivative of sine is what? Cos. Cos x. X just happens to be this lovely stuff. Okay, cool. I did the derivative of sine. Now I have to work through and do the derivative of cos. What's the derivative of cos? Negative sine, and then tan x is embedded. Then what do I have to follow behind with? The derivative of tan, which is secant squared x. Now you could leave it like this. What they will do is they'll take all the signs that come out of the trig and bring them to the front. So if like you had a negative and a negative, they'll bring it out as a positive. And in this case, there's a negative just sitting in the middle. They're not going to let the negative sit in the middle. If you see it on your textbook, they'll rewrite it as this whole thing with the negative in front. Because this is multiplied, like this is one thing multiplied by this one thing. So this is one chain. Because every chain gets an x, right? So they'll just bring the negative to the front. And then they'll go cos tan x, and then sine tan x, and then secant squared x. And these three could be out of order, it doesn't matter. If you're matching the textbook, they can put the sine tan x first, or they can put the secant squared x first, right? Okay, and this one you have to do product rule. So f prime of x, it's a numerical base to a variable exponent, so you rewrite it. Ln the base, which just happens to go away, ln of e. And I practice this because if the numerical base isn't e, you'll remember to write ln 4, or ln 5, or ln 8, right? And then you have to do a derivative of this product rule. So you have to follow behind with a product rule. So it's going to be g, which is cos 2x, times f prime. What's the derivative of f? A 1, because it's just x, right? This is f, this is g. So the derivative of f is 1, plus, so it's g f prime, f. What's the derivative, g prime, of cos 2x? It's the derivative of cos. Negative sine x. X just happens to be 2x. And what do I have to remember to do? Multiply by the 2, because I have to do the bracket in the inside. So g prime is actually negative 2 sine 2x. So I'm going to write that here. Negative 2 sine 2x. And this would be right, leaving it like that. However, they're just going to put the negative 2 and the x together, and move it to the front of that little divvy thing. So they're going to get e to the x cos 2x, bracket cos 2x, minus 2x sine 2x. Is how they'll clean it up. Now your homework was posted in Google Class, which we done Friday. I gave you the ones that you could do yesterday. Now you just have to do the other ones that I didn't assign. Okay? I put this whole assignment in Google Classroom to be posted all at once. So you did part of it yesterday, you'll finish the rest of it today, and you have about 30-ish.